Hi there, folks. Root Beer here, looking at B2 on the 2014 Canadian Open paper. Determine all integer values of n for which n squared plus 6n plus 24 is a perfect square. Okay, so I need this to be a perfect square. What could we do? What could we do? Well, we'll get the previous question out of the way. It's n squared plus 6n plus 24, and I need this to be a perfect square. So really what we're looking for is solutions to something like this. Okay? And so you could rearrange, you could plug in with the quadratic formula, although it's just struck me for a moment that there might be something else we can do. So we could try and solve this, and you'll keep a k in there, and you'll get certain values. Oh, what the heck, I've got a video I can do both methods, and see which ones work and which ones don't. So what could we do? Well, n has got to be negative b plus or minus the square root of b squared. Oops, b squared is already 36. Minus 4, and then what is my a? It's 1. What is my c? 24 minus k squared, all over 2a. Now I can divide by 2 on the top. I'll get negative 3 plus or minus. And when we divide by 2 inside a square root sign, we actually have to divide by 4. So 9 minus, and then it's 24, and then minus minus k squared. So negative 3 plus or minus. 9 minus 24 is negative 15. We get k squared minus 15. So that's what our n has to look like. Now, a few things. N has to be an integer, right? So n's got to be an integer. Negative 3, that's already an integer. That's fine. But that means that k squared minus 15 has to be, or the square root of k squared minus 15 has to be an integer. So k squared minus 15 has to be a square. And you might think, well, now we're sort of going around in circles a little bit. Now, these numbers are small enough that you could probably guess and check, but this is actually going to lead me into my next method, which I think might be a faster way to do the question. So we get k squared minus m squared has to be 15, and this is a difference of squares, which is a nice factorization. If you're not familiar with it, then I would recommend you get familiar with it, because it pops up all the time, pops up in lots of places. But k squared minus m squared can always be factored as k minus m times k plus m. But k is an integer, and this m has to be an integer. So we've got k minus m as an integer, k plus m as an integer, equal 15. These have to be factors of 15. So what could we do? Well, 15 has a few factors. 15, 5, 3, 1, negative 1, negative 3, negative 5, negative 15, and they sort of come in pairs. It's quite nice and neat. So what could we have? Well, we could have k minus m, and then the corresponding k plus m. And how would we figure out k and m from there? Well, k is going to be 2k over 2. And how would we get 2k? Just add the two expressions together. And similarly, m is found by subtracting the 2 and dividing by 2. Okay, and hopefully we get k and m as nice, neat integers. What can we do? Well, we could have negative 15, negative 1. We could have negative 5, negative 3. Negative 3, negative 5, negative 1, negative 15. And just increasing here. 3, 5, 15, 1, 3, and 5 here. Okay, add them up and divide by 2. K would be negative 8. And so m would have to be 7. No, m would have to be 7, yeah. In order to get this minus 1 when we add k and m. Or we could get negative 4, and then this would be 1. Or negative 4, and this is negative 2. No, sorry, negative 1. Or we could have do we have? 1 and 15 would be 16 divided by 2 is 8. You'll also get an 8 here, and a 4 here, and a 4 here. And so your m could be 7 or minus 7. I feel like I've missed one. Yeah, I've missed one in here, minus 8. And you'd be looking at minus 7. 7 and then 3 and 5. So you'd have to have a 1 here and a minus 1 here. So there's only so many values for m that we can have, and there's only so many values for k that we can have. So k squared is either 16 or 64. M squared is either 49 or 1. Okay? So how does this factor into things? Well, n was negative 3 plus or minus the square root of k squared minus 15, but we said that was m squared. So negative 3 plus or minus the square root of 49, or negative 3 plus or minus the square root of 1. So n is negative 3 plus or minus 7, or negative 3 plus or minus 1. And so that's either 4, 10, or minus 4, minus 2. Okay? And we should, with each of these options of n, get squares for k. And we're looking at things like 64 or 16. And we could double check. N squared plus 6n plus 24. If I plug in 10, I get 100 plus 60 plus 24. And that should be 184. Something seems to have gone wrong. 184 is not a square. So, what did I do wrong is, of course, the natural question. Oh, this should be a negative 10. Minus sign there, so then we get 40 plus 24 is 64. There we go. If I plug in 4, I get 16 plus 24 plus 24, and that's 16 plus 48, which is again 64. Or over here, we could get 16 minus 24 plus 24, which is 16, as predicted. Or 4 minus 12 plus 24. Minus 12 and 24 is just 12, plus 4 is 16. So, as our final answer, here's our values of n. They wanted the values, not how many. Yeah, determine all integer values of n. So we would just want to write them down here, where it says final answer. Okay, so that's one way to do the question, although it was a little long, and it took a little while to get into difference of squares. Here's what I think might be a faster way, and we'll just explore. If you're satisfied with the way I did the question and the answer there, feel free to move on. Up next will be B3, yada, yada, yada. You know, like, subscribe, all that usual stuff that I sometimes cram in at the end. But if you want to, stick around, and we can take a look at another way to do the question. So we had n squared plus 6n plus 24, and we want that to be equal to a square, right? Well, one thing I think we could do is maybe do a difference of squares like this. Complete the square over here. Okay, so this is going to be n plus 3 squared. And bring the k squared over here, and we get 15. And now we're sort of jumping ahead to, we didn't have to do a quadratic formula or anything like that. We can, I'm jumping ahead now, we can factor this as n plus 3 minus k times n plus 3 plus k. And that's got to be equal to 15. And again, we have the same sort of factorings that can happen. And you might say, well, okay, it's still 15. What's the significance of that? Remember, m is roughly n plus 3, based on sort of our formulas over here. But we make our chart a little faster, and can actually solve for the values of n at the end. So k is, you add them up and divide by 2. Oh no, you subtract them this time. K is on the other side. And n plus 3 is found by adding them up and dividing by 2. Just abbreviate that. And then n, you would just subtract whatever you get in that column there. So we could have minus 15 minus 1, and that would lead to minus 8 for your n plus 3. And then n would be negative 11. I feel like I've messed something up here. It is n plus 3 squared. Oh, I've got a minus sign here, so I have things on the wrong side. There we go, so just correct that. The k, what we want to do is bring this over to the other side so the 15 stays where it is. There we go, and so that factors as k minus n plus 3, and k plus n plus 3. There we go. So just switch this. So k is still found by doing the plus. Okay, that makes a lot more sense to me. There we go. If you're worried I wouldn't have caught that mistake, remember I try and check my answers, and I did check my answers with the first method that we used, so I probably would have checked my n's at the end to find my mistake. And it's always a good idea to check your answers if you think you've got some. Okay, so it would be k minus n plus 1, k plus n plus, or sorry, n plus 3. I said n minus 1. Okay. So there we go, and then we'd have k is negative 8, and we'd have n plus 3 is 7, so n would be 4. And look at that, n equals 4 was one of our possible answers. Minus 5, minus 3, minus 3, minus 5, minus 1, minus 15, 1, 3, 5, 15. And we would just go about filling this in as usual. So minus 7 would give us the minus 10, and there's the other minus 10. And then we could have minus 4 or minus 4, or 4 or 4 for our values for k. And then we get 1 minus 1, minus 1, 1 here. And the order there's... Nope. I've screwed that up again. I was wondering why the order swapped. And so an n plus 3 of 1 gives me an n of negative 2. And then we also get negative 4 there. Okay, and if we check, negative 4, negative 2, those were our other answers. So I'd say it's a little faster. Don't have to mess around with the quadratic formula. Just difference of squares. Both parts came down to difference of squares. I guess maybe it's just a question of how quickly you realized it. All right. So that clears the way for, what did I say earlier? B3. B3 is up next. So we'll take a look at B3, or rather I would encourage you to take a look at B3 now. Well, not now. I mean, pause the video if you want to. But look at it before watching the next video to see, could you get it? Will you get it a different way? Those sorts of things. Because that's how we do well, is we practice. And maybe this next question isn't exactly what you're going to see on this year's Open, but you're getting your brain working, you're stretching your problem-solving skills, and that's what's important. So I will see you for B3 next time.